Hello everyone and welcome to our final video for Unit 5, 8.4 Powers and Roots of Complex Numbers in Polar Form. So in the last video we talked about multiplying two polar form expressions to get a new polar form expression and then converting it to rectangular form. We also talked about dividing two polar form expressions to a new polar form expression and then converting to rectangular form. Now what we're going to be doing is raising the polar form expressions to a power or taking a root of that polar form expression. Okay, for example, in number 1 we have 2 cosine I sine 30 degrees and we're raising it to the 5th power, which means that we're going to follow formula number 1 up here, this one right here, that if I raise the expression to a power, I'm going to raise r to that power, but then multiply theta by the power. So what does that mean? It means that this is really going to be 2 to the 5th power cosine I sine 5 multiplied by 30. And that's going to give us our new polar form expression. 2 to the 5th power, that's 2 times 2 times 2 times 2 times 2. Let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Cosine I sine of 150 degrees. Now we want answers in standard form, which means going from polar to rectangular. And we know how to do it from this part. Once we get past this formula, it's just like what we've been doing. We're going to do 32 multiplied by cosine of 150 plus I sine of 150. Well, just a picture for reference, 150 degrees, that's right here. We have 180 is right here. We're on 150. That means this is a 30-degree angle. 1, 2, negative root 3. So we're going to do cosine of 150. That's negative root 3 over 2. Plus I sine. Sine is going to be 1/2. Okay, we multiply 32 and distribute. We get negative 16 root 3 and 16i. So as you can see, it's not a very difficult thing to do. Yet again, as I always say, not difficult, just takes a little bit of time and a little bit of work. Okay, let me scroll down just a little bit. All right, with number 2, first thing we got to do is we have to convert this into polar form. So we know that x is equal to 1, y is equal to root 3, r is going to be 2, and theta has to be square root of 3 over 1 for our tangent. That means we're talking about square root of 3, so it's 60 degrees. The more you practice this setup, the quicker you're going to get at figuring out what theta and r is going to be without a calculator. Okay, so that means that this is really 2 cosine I sine 60 degrees raised to the 8th power. Well, raising it to the 8th power, remember that r gets raised to the power, so 2 to the 8th cosine I sine 8 times 60, because theta gets multiplied. Okay. Well, 2 to the 8th power, we already knew that 2 to the 5th is 32. 2 to the 8th is 256 cosine I sine of 480 degrees. All right, picture for reference. So I go around 360 degrees, and then I've got to go around another 120 degrees. That means this is a 60-degree angle. So that's root 3, negative 1, and 2. Now we do what we normally do. 256 cosine of the 480 degrees plus I sine of the 480 degrees. Well, cosine of this 480 is negative 1/2. Sine of the 480 is square root of 3 over 2. Multiply it out. We get negative 128 plus 128 root 3. Okay. Number 3. Yet again, we got to convert. So we got x, y, r, theta. X is 3, y is negative 3. That means r is 3 root 2. Theta, think about theta, we got tangent has to be negative 3 over 3 or negative 1 over 1. So y is negative, x is positive. We're talking about fourth quadrant, negative 1 and 1. That makes this 315 degrees. Or we could technically say it's negative 45 degrees. Either one of these would come out the same because those are the same angle. One going counterclockwise, the other going clockwise. And in this case, I'm going to use the negative 45. Since I see I'm going to have to multiply it by 7. Okay, so conversion, we've got 3 root 2 cosine I sine of negative 45 degrees raised to the 7th power. Okay, that means I need to raise 3 square root of 2 to the 7th power. That comes out to be 17496 root 2 when you plug it in your calculator. Cosine I sine, and we have negative 45 multiplied by 7. That's negative 315. Okay, picture for reference, negative 315 means comes around and makes a 45-degree angle right here. 1, 1, square root 2. So 17496 root 2 times cosine of negative 315 plus I sine of negative 315. Well, cosine of negative 315 and sine of negative 315 are both square root of 2 over 2. So this multiplied by square root 2 over 2 plus square root 2 over 2i, which another way to write this, which I found to be a little bit easier, is I wrote them as 1 over root 2 plus 1 over root 2, because that means this root 2 cancels with all of them. It means I have 17496 plus 17496i. Little trick. That way I don't have to do square root 2 times square root 2, making 2, multiply it by this, divide by 2. Saves me a little bit of work in writing them in this way. Okay, not hard, just a little bit of work. Now we're going to shift gears just a little bit, and we are going to go to finding cube roots. Now, that means we're going to be using the second formula up here, which means if I take the cube root of the expression, I take the cube root or the nth root of r, cosine I sine theta plus k 360 over n, which is that whatever that index is. So let's look and see what that means with an example. So I'm finding cube roots, which means n is going to be the number 3. My index is 3. So it says if I'm going to cube root this, I cube root r, then I do cosine I sine of theta plus 360k divided by that index, which is 3. And we're going to leave these in trig form, so we don't have to go to rectangular form. Okay, so cube root of 125, that's 5. Cosine I sine. Now both of these numbers divide by 3, so I'm going to do that. 240 divided by 3, that's 80. 360 divided by 3 is 120. Don't forget the k. And this is done. That is the answer. That's in trig form, and it allows me to plug in values for k. Now, k is going to be 0, 1, 2, ... all the way till n minus 1, which in this case means the cutoff is right there. K can be 0, 1, and 2. Now we're not going to plug those in and see what these are, but this leaves the expression open to plug in these values if we did need to. Okay. Looking at let me do number 6. That way you can do the U try on 5 and 7. That way you get one like this one and one like this one. Alright, first I've got to get it in polar form. So we know x is negative 64, y is 0, r is 8, and I need to know theta. Well, tangent theta is 0 over negative 64. Thinking of that in a little bit different light, y is a 0 and x is a negative number. That's 180 degrees. Because we're talking about x being a negative number but y being 0, that's 180 degrees quadrantal angle. So that means this is 8 cosine I sine of 180 degrees. Now we take the cube root. So I take the cube root of 8 cosine I sine theta, so 180, plus 360k divided by our index, which in this case is 3. Well, cube root of 8, that's 2. Cosine I sine. Both of these numbers, yet again, divide by 3. 180 divided by 3 is 60. 360 divided by 3 is 120. K. And there's our answer. All right, so as I said, 5 and 7 are going to be your U-try problems. I'm going to go ahead and condense this as 27 cosine I sine of 27. Okay, just so that's condensed. All right, so you try 5 and 7, pause the video, work them out, and then come back for the answer. Okay, hopefully you paused the video at this point and are back now to check your answer. So for this one, it's already in polar form, so I take the cube root of 27, cosine I sine, 27 plus 360k over 3. And that goes down to cube root 27 is 3 cosine I sine. 27 divided by 3 is 9. 360 divided by 3 is 120k. And there's our answer. For 8i, I need to go ahead and convert. So x is 0, y is 8, r is 8, theta. So if y is a number but x is 0, y is a positive number, that means we're talking about theta being 90 degrees. So I've got 8 cosine I sine of 90. Take the cube root of 8, that's 2 cosine I sine. 90 divided by that 3 is going to be 30 plus 120k. And there's our answer for that one. All right, and the last one that we have two more, our last two problems for this video, and then we're done, is we're going to solve the following equations by taking the nth root of both sides, converting the expressions to trig form, then calculating the nth root, and then leave the answers in trig form. Okay. The way we're going to do this is I'm going to actually move this up a little bit, cut off number 9, and scroll this down so we got nothing but workspace and one problem. All right, we're going to set this up and solve for x, or at least get it into x to the 4th by itself. So I'm going to add 7. 7x to the 4th equals 7. Divide by 7. So x to the 4th is equal to 1. Well, if we took the 4th root of 1 is 1. Right? So it's actually like plus or minus 1. So what we're going to do from this point is we're going to say that this expression tells me that x is equal to 1. We're also going to say that y is equal to 0. There is no y in this expression. We don't have one. From here, we're going to calculate r. r is 1. 1 squared plus 0 squared equals r squared, so r has to be 1. And I need theta. Excuse me. Well, theta has to be when x is 1, y is 0. That's 0. Okay, so we're talking about, just for reference, 0.10, x is 1, y is 0, r is also 1, so that's 1, 0, which is at 0 degrees, or 360 degrees, but I'm going to use 0. Now I'm going to convert that into polar form, so that means r is 1 cosine I sine of 0 degrees. Now I want to take the 4th root, because we're talking about x to the 4th, so it's going to be the 4th root. So 4th root of 1 cosine I sine, and I'm going to have 0 plus 360k divided by 4. Well, 4th root of 1 is 1. Cosine I sine of 0 divided by 4 is 0. Plus 360 divided by 4 is 90k. So really we're talking about 1 cosine I sine of 90k. And in this case, remember that k can be anything up to n minus 1. So k is going to be 0, 1, 2, and 3. And we're going to leave it in trig form. So this is it. And last problem, number 9. And make sure we have plenty of workspace. Same thing, we got x cubed is equal to negative 125. We move the 125 over. And we're talking about finding a cube root this time. So x, we say this expression tells me x is equal to negative 125. Y is equal to 0. R is equal to 125. Theta is equal to 0 again because we got a positive, oh, sorry about that, told you the wrong one. Theta is equal to, we got a negative x and no y, that's 180. Okay, so let's plug them in. We got 125 cosine I sine of 180. Now we take the cube root, because we're talking about 3, so cube root of 125 cosine I sine of 180 plus 360k divided by 3. Cube root 125 is 5. Cosine I sine 180 divided by 3 is 60. 360 divided by 3 is 120. And in this case, k is 0, 1, and 2. And there is our answer. Alright, with that, guys, that is the end of Unit 5. That's the end of our powers of complex. You will have a test. It's probably going to be middle of next week, because then your final exam will be either on the 29th or the 4th of May. So I'm thinking test on the 28th. It'll give you about a week to go over this, and you only got a few videos to go over and a little bit of homework, not long homework assignments. Alright, so I'll see you guys later.